Welcome to my channel. In this video, I am going to discuss how to write the laboratory manual for verification of the Tellegen'S theorem for two networks of same topology. So, this manual has been written to verify Tellegen'S theorem considering two networks which are of same topology. So, first of all, we must know how to write the record or observation if you are studying electrical engineering. So you must know how to write the record or observation. For that, I have in this slide I have shown it clearly. So let us assume this is our right side page of your observation or record. This is the left side page of your observation or record. On the right side page, at the top you must write the title. On the top left corner in your observation, on the right side page you must write date and experiment number. So on the right side pages you must write aim, apparatus required, theory, procedure, formulae, calculations, theoretical proof, practical proof, precautions and results. Only on the right side pages. On the left side pages you must draw the circuit diagram, you must draw the observation tables, and if model graphs are available you must draw the model graphs only on the left side pages of your observation or record. So this procedure you must follow for any experiment that you are going to write in the observation or the record of electrical engineering. Now let us get back to our manual. So the title of our this manual is verification of the Tellegen'S theorem for two networks of same topology. This is the title. So if you want to note down this, you can note it down. Verification of the Tellegen'S theorem for two networks of same topology. So this is the title. Now the aim. So here I have written this manual for both hardware experiment as well as for software experiment using MATLAB software. So if you are going to do the experiment using MATLAB software also, you can write two aims. If you are going to do the experiment in your laboratory using only hardware, you can write only part A here. I have divided aim into two parts, part A and part B. So for hardware experiment, the aim is part A. For software experiment using MATLAB, the aim is part B. So since I have written this manual for both hardware as well as for MATLAB software experiment, that's why I have written two aims here. So my first aim is to verify the Tellegen'S theorem for two networks of same topology using hardware. Another part of this aim is to verify Tellegen'S theorem for two networks of same topology using MATLAB software. So in your college, if you have only hardware experiment, no need to write part B, you write only part A. So if you want to note down this in your observation, you can pause this video and you can copy down this aim in your observation or record. Now on the right side page, next after aim you must write the apparatus required. The apparatus required for hardware experiment are, for Tellegen'S, to verify Tellegen'S theorem, we need a regulated power supply, we need circuit board, ammeter, voltmeter and connecting wires. So here actually I am going to end this show. Actually what you require, regulated power supplies you require two. Okay, regulated power supplies you require two, and circuit boards you require two of same circuit boards. Okay, two networks of same topology, so circuit boards you require two, and ammeters you require 0 to 50 milliamperes MC type. Number of ammeters that you require for the circuit that I have considered, for that particular circuit you require Approximately for my circuit, I have written here 1, but actually you require 4 for the circuit that I have considered. Okay. No, it is more than 4, it is 5. Okay. So I will show you the circuit in the next slide. So actually I require approximately 5 ammeters, and for the circuit that I have considered, 2 circuits of same topology for those 2 circuits. When we connect them together to perform this, to verify Tellegen'S theorem. So the number of voltmeters that I require is around approximately 8 voltmeters we require. Okay, so even if we have 1 ammeter and 1 voltmeter, we have to reconnect the circuit again and again. Means wherever you want to measure the current, you can connect that one particular ammeter, and you can turn on the supply and you can measure the current at that particular location. So we can even manage using only 1 voltmeter and 1 ammeter also we can do this experiment. So but for the circuit that I have considered, so I need at least 5 ammeters and I need at least 8 voltmeters. Okay, so these are the apparatus required. So regulated power supply of 0 to 30 volts 1 ampere. Number of regulated power supply required is 2. Circuit boards, I need 2 circuits, same circuits. Ammeter 0 to 50 milliamperes MC type, approximately 5 ammeters I require for my circuit which I have considered. I will show it in the next slide. Voltmeters I require around 0 to 30 volts range type, MC type, around 8 voltmeters for my circuit. Okay, and connecting wires as per the requirement. Okay, so let us and the apparatus required for software experiment is what? MATLAB. Okay, the apparatus that are required for software experiment is MATLAB. You can pause the video to go through the apparatus and you can note it down in your observation. Okay. Now let us see the circuit diagram. This is the circuit diagram. So here you can see a 47 ohms resistor, 510 ohms resistor and 2000 ohms resistor. So this is a T network. Okay, and you just see 47 ohms, 510 ohms and 2000 ohms. So this is circuit 1. This is circuit 2. Okay, so if you observe carefully, both circuit parameters are same. So I have taken 2 circuits of same topology here. I have connected them together. Okay, so both circuits 47 ohms, 510 ohms, 2000, 47, 510, 2000. So I have taken 2 circuits of same topology here. Okay, so you just connect regulator power supply to this 47 ohms. Okay, and regulator power supply to this 510 ohms, and connect these 2 circuits, and in between you just place an ammeter. So here regulator power supply positive is connected to ammeter positive because we want to measure the current as well as voltage here. That's why we have connected an ammeter in series to the RPS1. Okay, so to RPS1, this is RPS1. What is the range of RPS here? 0 to 30 volts 1 ampere, and let us assume that notation of this RPS1 notation, voltage notation, that let us give it as V1. Okay, so to V1 positive terminal connect ammeter positive, ammeter negative is connected to 47 ohms. Okay, and if you have a circuit board which has both 47, 510 and 2000, it is okay. If you don't have a circuit board, simply connect ammeter negative to 47, other terminal of 47 ohms connected to 2000, and one of the terminal of 510 connected to the 2000, and a negative terminal we can say positive terminal to 2000, negative terminal of 510. So even if you there won't be any positive or negative terminals for the passive elements, you can connect any terminal to any element. So the other terminal of 510 connect to ammeter positive, ammeter negative must be connected to 47 ohms, other terminal 47 should be connected to 2000, and 510 ohms, one of the terminals should be connected to 2000, and 510 it should be connected to negative of one of the ammeters, and positive of ammeter must be connected to the RPS2. So RPS2 range is 0 to 30 volts 1 ampere, notation is V2. Across RPS2 connect a voltmeter to measure the voltage. Similarly across RPS1, this is RPS2, across RPS2 connect voltmeter of range 0 to 30 volts MC type. Similarly across RPS 1 connect voltmeter of range 0 to 30 volts MC type. Okay, and across each resistor you can see across 47 ohms, this 47 ohms connect a voltmeter of 0 to 30 volts MC type. Across 510 ohms connect a voltmeter of 0 to 30 volts MC type. Across this 47 ohms connect voltmeter of 0 to 30 volts MC type. Across this resistor 510 ohms connect voltmeter of 0 to 30 volts MC type. Across this 2000 ohms resistor connect voltmeter of 0 to 30 volts MC type. Across this 2000 ohms resistor connect voltage of voltmeter of 0 to 30 volts MC type, and in series to each and every resistor connect ammeter. So we want to measure the power here, that's why. So in series to 47 already this ammeter I have already explained it to you. In series to 510 connected this ammeter, that is in series to both 510 as well as 47 ohms. In series to 2000 ohms connect an ammeter of 0 to 50 milliamperes MC type. In series to this 2000 ohms connect an ammeter of 0 to 50 milliamperes MC type. Okay, and in series to this 510 ohms already I have explained. Okay, you can connect an ammeter of 0 to 50 milliamperes MC type. So all the voltmeters that we are using here are of 0 to 30 volts MC type in this circuit, and all the ammeters are of range 0 to 50 milliamperes MC type. So this is the circuit to do the hardware experiment. So you must put the variable symbol. You can see here there is a variable symbol here. You must put the variable symbol. Why? Because we are going to vary the voltage using the RPS until the required voltage is obtained. So put the variable symbol across the RPS, across the positive and negative terminal of the source. That is RPS. So this is the circuit for the hardware experiment. You people can just pause the video and just draw the circuit in your observation or record. Now similarly you can draw the circuit, or you can design the circuit using MATLAB software. So this is the circuit. This circuit is a bit complicated, but it may look complicated, but it is not complicated. If you see here, this is 47 ohms, 510 ohms, 2000 ohms. Okay, 47 ohms, 510 ohms, 2000 ohms. Same elements. Okay, same elements are here. Okay, so this is my DC voltage source of 30 volts, and across it I have connected a voltage measuring element, voltage measurement, and output of this voltage measurement I have given it to the product. You can see X here, X. So this is the product element. Okay, and you can see in series to 47 ohms I have connected an ammeter of ammeter. I should not say ammeter. Why? Because this is MATLAB software experiment. So I have connected an current measurement. So this is my current measurement element. Okay, so across 47 ohms connect voltage measurement element. This is voltage measurement. Across 510 ohms connect voltage measurement. Across 2000 ohms connect voltage measurement. Okay, across this 47 connect voltage measurement. Across this 510 ohms connect voltage measurement. Across 2000 ohms connect voltage measurement using MATLAB software. I will just erase all links. Okay. So and in series to 47 ohms connect current measurement. In series to 510 as well as 47 ohms connect current measuring element. This is current measuring element. In series to 2000 ohms connect current measuring element. In series to this 2000 also connect current measuring element. In series to this 510 ohms connect current measuring element. Okay. And I decided to calculate the power delivered and power absorbed. If you see here, it is mentioned here, this is power delivered, this is power absorbed. So directly I am calculating the power delivered and power absorbed by using this circuit. So that's why I have multiplied voltage and current in each branch. So see, this is the P, this is product X. So this is the product of this current and this voltage. Another, this is my voltage and this current I have multiplied it. So this is it. Next, this is voltage and this is my current. This is the product. Okay. Similarly, this is current and this is voltage. This is my product. Similarly, this is my voltage measuring element and this is my, where is it? This is my current measuring element. This is the product. V into I. That's what I have done. At last, I have added all the products. Okay. I have added all the products. Okay. And I have calculated the power absorbed and power delivered. Okay. So this circuit may look complicated, but it is actually simple circuit. So you also require power guide. So using MATLAB software, don't forget to draw the power guide. So I thought you can take the you just pause the video and you can copy it on the circuit, or I thought I will zoom it so that it will be more clearly visible to you. I will zoom the first part. So I will just expand it. Let me see. This is it. 1 second. I will just. Earlier, how was it? This is how it was looking like. Okay. So if it is visible to you people, whoever wants to copy this circuit diagram, if it is visible to you people, you can draw it. You just pause the video and you can draw it in your notes. Okay. So for me it is visible because I am using the system, and I thought I will just expand this. Huh? I have expanded it. So whoever wants, this is first part. Okay, left side portion. I am showing you only the left side portion. You can pause the video. Now it may be when compared to the previous image. This is not the full image. I am showing you only a part. Why? Because it looks a bit more components are there, isn't it? We have connected more elements here. So all the elements, because of all the elements, the circuit was bit congested. So I just expanded it. You can pause the video and you can copy this circuit, and after a minute I will just I will show you the other part. So whoever is copying it down, you can pause the video and you can draw it in your notes or observations. So first part, that was first part. Now this is the second part. Second part means the right side portion. Earlier I have shown you left side portion. This is right side portion. I have expanded so that it is more clearer to you to copy it down in your observation. You can pause the video and you can just draw the circuit. So I'll proceed further. So this is the whole circuit. So since it was a big circuit, that's why I just expanded it and shown you in two parts. So this is it. So you can copy it down. So if the whole circuit is shown on this single slide, it looks much more complicated. That's why earlier I have expanded it and shown it to you. So this is the software experiment circuit. Okay, this is the software experiment circuit. Now let us see the observation tables for this. For hardware experiment. For hardware experiment, to determine power delivered. So here source will deliver the power and passive elements will absorb the power. So here how many sources are there? Two sources are there, source 1 and source 2, the RPS 1 and RPS 2. So theoretically you have to calculate the source voltage and source current. Where is it, my cursor? Okay. So theoretically you have to do the calculations and note down VS1, source 1 voltage and source 2 voltage, and source 2 voltage and source 2 current, and doing hardware experiment. Okay, while doing the hardware experiment, write down source 1 voltage, source 1 current, source 2 voltage and source 2 current. Okay, so power delivered is obtained from the sources. Okay, so this is the table to determine the power delivered. You can pause the video and you can draw this tabular column in your observation. Okay, you can pause the video and you just copy it down. Next, power absorbed. To determine what? To determine power absorbed. Okay. So, voltage across the resistor 1, current across the resistor 1, means current flowing through the resistor 1, voltage across resistor 2, current flowing through resistor 2, voltage across resistor 3, current flowing through resistor 3, voltage across resistor 4, current flowing through resistor 4, voltage across resistor 5, current flowing through resistor 5, voltage across resistor 6 and current flowing through resistor 6. Okay, so theoretically we have to calculate all these terms and you must tabulate it. You must tabulate in the theoretical values. You must tabulate the theoretical values in this tabular column After doing hardware experiment, okay, after doing hardware experiment, you must note down all these values from the voltmeter and ammeter. Okay, so you can pause the video. You just copy. I'm sorry. You just copy this tabular column in your observation or record. So after copying down this observation table for determining the power absorbed and power delivered for the hardware experiment, let us go for the software experiment. So for software, no need to note down the voltages and currents as we have done for the hardware. You can do that also, but I have simplified it. Simply directly from the circuit that I have designed, from that circuit, you can directly note down the power absorbed and power delivered. Okay, power delivered and power absorbed directly from the circuit. When you design that circuit in your MATLAB using MATLAB software, and you will directly get the power delivered and power absorbed values. Okay, just copy down this tabular column in your notes. Okay, this is it. So you must also write the theory. Next theory, you must write the theory in your record. In the observation, you can just put a heading theory and you can leave it. At least you just leave at least one page to write the theory in your record. Now, after writing theory, let us see the procedure, how to do the experiment. For hardware experiment, procedure is connections are made as per the circuit diagram. Okay, we have to apply a voltage of 30 volts using the regulator power supply 1 and 2. Okay, and we have to note down the ammeter readings and voltmeter readings, and you must note down those readings in the tabular columns. Okay, after that we have to calculate the total power delivered by the sources and total power absorbed by the circuit elements, that is passive elements. And later we have to verify the Tellegen'S theorem by simply comparing the power delivered with the power absorbed, power delivered by the source with the power absorbed by the passive elements. Okay, so this is the procedure for Tellegen'S theorem. To verify Tellegen'S theorem for two networks of same topology. So we have taken here two T networks and we have connected them. And we have connected ammeters, voltmeters across the elements and ammeters in series to the elements. And there are two sources which are delivering the power. And so the sum of powers delivered by these two sources must be equal to the sum of the powers absorbed by all the elements in the given circuit. Okay, so this is the procedure. You can pause the video and you can copy down this in your observation or record. Now let us see the procedure for the software experiment. So procedure for software experiment. So first of all, enter the command window of the MATLAB. Okay, enter the command window of the MATLAB. Next, you have to create an new model by selecting file. After selecting file, you just click with the left button of your mouse on the file when you open the MATLAB. Okay, and after that you just click on the new, and later you just click on the model. So now untitled page will be open. Okay, and you also open the Simulink library. Now pick up the blocks. Now pick up the blocks from the Simulink library browser and connect the blocks. Okay, so you have to pick the blocks from the Simulink library browser and you just collect them and save them in the model, and after that you just connect those blocks. After giving connections to those blocks, assign the values of each block. If it is a resistor, you just assign the resistance value. If it is a source, you just put the source voltage value. Okay, after that, okay, so you have to set the source and parameter values. Parameters means here passive elements values. Okay, circuit elements values. Okay, so I can say here for software experiment I can say circuit elements values. Okay, sources as well as parameter means resistive elements. Okay, instead of parameters I can write, I have written here parameters. You can write passive elements. Okay, so I can mention there as passive elements. So no need to mention it as parameter. Simply you can write circuit elements. Okay, passive circuit elements. Instead of parameter, you can write passive circuit elements. I have written here parameters. It's okay, whatever I have written. After that, you have to debug and run the circuit. Okay, so when you debug and run the circuit, you must observe that power delivered is equal to the power absorbed. Then only Tellegen'S theorem will be verified. Okay, power delivered must be equal to the power absorbed. If that condition is satisfied, then Tellegen'S theorem is verified. Otherwise, it is not verified for the given circuits which are connected together and which are of same topology. Okay, two networks of same topology. So this is the procedure to do the experiment using MATLAB software. So you can pause the video and you can note down the procedure. Now let us see the formulas. So formulas are, there are two sources. So first of all you have to calculate power delivered by source 1. Formula is PS1 is equal to VS1 into IS1 in milliwatts. Similarly, power delivered by source 2. Formula is PS2, that is power delivered by source 2. P means power, S means source 2. Okay, the source is 2, so source 2. PS2 is equal to VS2 into IS2 milliwatts. Okay, so total power delivered is PS1 plus PS2 in milliwatts. So these are the formulas to calculate the power delivered by the sources. Okay, you can pause the video and you just copy down this formulas in your observation or record. And now let us see these are the formulas for power delivered. Now let us see the power delivered by absorbed, not delivered, absorbed by the circuit elements. So there are there are 6 resistors, not approximately, but exactly there are 6 resistors in my given in the Tellegen'S circuit if you carefully observe. So calculate the power across each resistor. So across resistor 1 power is PR1 equal to VR1 into IR1, which is in milliwatts. Next, power across resistor 2 is VR2 into IR2 in milliwatts. Power across resistor 3 is VR3 into IR3 in milliwatts. Power across resistor 4 is VR4 and IR4. Power across resistor 5 is VR5 into IR5. Power across resistor 6 is VR6 into IR6. Okay, so total power absorbed, you just add PR1, PR1, PR2, PR3, PR4 and PR5, PR6. You just add them. You will get the total power absorbed. Okay, you will get the total power absorbed by all the resistive elements or circuit elements, passive elements. Pause the video and you just copy down this. Now, using those formulas, you can perform the calculations. So, in order to do the calculations in your observation, if you are writing the observation, leave at least 2 pages to perform the calculations. To do the calculations, we can say. After leaving 2 pages for calculations, write theoretical proof and leave at least half a page. Write theoretical proof and leave at least half a page. After that, write practical proof and leave at least half a page. After that, precautions. So initially keep the RPS output voltage knob in 0 volt position. Where is my cursor? Yeah, in 0 volt position. Avoid loose connections and avoid short circuit of RPS to output terminals. Okay, so these are all the precautions that we have to follow while doing the experiment. You can pause the video and you just note down the precautions. Okay. So at last, after writing precautions, at last result. So result you must write after doing the experiment. So you can write in the result that for the given 2 networks of same topology, Tellegen'S theorem is verified using both hardware as well as using MATLAB software. Okay. For the given networks of same topology, Tellegen'S theorem is verified using both hardware and MATLAB software. So that's it. This is the manual for verification of Tellegen'S theorem. for two networks of same topology using hardware as well as using MATLAB software. So if you like this video, you can click on the like button, and if you want me to make more videos which are related to electrical engineering, you just mention the comment section. See if any part which was not clear to you, and if you want me to make any changes in this manual, you can mention in the comment section. Thank you for watching this video.